Hello everyone, in this video lecture we are going to see about keyboard display controller 8279. First we will see the issues involved in your LED display interfacing. So I have taken a 7 segment LED display interfacing. So if you take a 7 segment LED display interface, for a segment to glow it needs 20 milliamperes. So including the decimal point, if you take it is 8 segments, so approximately it needs 160 milliamperes. So which is beyond the TTL capability. And if at all I connect more display devices, then more current milliampere is to be supplied. So first let me see a simple 7 segment LED display unit. So this is a 7 segment LED display unit which has got segments A, B, C, D, E, F, G along with the decimal point. Okay, it can be of two types. One is common anode and common cathode. In case of common anode, the anode of all the LEDs are connected to the positive 5 volt and the cathode is being driven by the processor. Okay, so it is A to G along with the decimal point. If the value of A to G is going to be 0, only for the bits which are 0, those LEDs alone will glow. So if at all AC alone is being 0, then only the LED A and C will be glowing up, the rest will not be glowing up. In case of your common cathode, all the cathodes of the LED terminals, they are connected to the ground. So anode will be driven by the processor. Okay, so this will be issuing the code like A to G along with the decimal point. If at all the A value is here, for the LED to glow, the value of A to G along with the decimal point, it has to be 1. Only when the value is 1, the LED will be glown up. So if I take the bits, or if I take the bit B, E alone is being made 1, only these two LED will glow, the rest of the LEDs will not glow up. So we have seen that more amount of current is needed to make your display lit up. Okay, so therefore to reduce this problem we can go for multiplexed display. So by the way of multiplexing, we are going to select only one of the display at a time and make it glow. Okay, so the rest of the display will not be glowing it up. You can see here at the top there are some few transistors. These are all the digital switches. So whenever the select 0 is get selected, so only this transistor will switch on. That means unit 0 will get selected. And since this is your common anode mode, all this has been driven to by zeros. Only when the segment value is going to be 0, the corresponding LED segments is going to glow up. So you can see here it is A bar to G bar and decimal point bar. So this has been given. So this has been connected to all the display, but only this unit is being selected, only this is being switched on. So therefore only this segment or this 7 segment display unit alone is selected for displaying. So the other unit will not get displayed. So if at all the display is glowing for 2 milliseconds, assume that it is glowing for 2 milliseconds, then the next I glow it up for 2 milliseconds, next I glow it up for 2 milliseconds, then after 16 milliseconds I can come back here. So within a 16 milliseconds, after 16 or 18, it is 16 milliseconds takes here, at the 18th millisecond I will come up here. So when it is driving at the 18th millisecond, your eye will not visualize that it has been blown for 2, this is for 2, this is for 2, because your eye has got some retention power, so which makes it appears that as if all the display is being blown all the time. Okay, so for that we need some high current so that the display appears brighter. So normally we need 20 milliamps for a segment. In this cases like multiplex, we can go with 30 to 40 milliamperes. Okay, so that the display will be brighter and it will appear as if the display is being glown all the time. All the display units have been glown all the time, but only one display would have been glown at a time. Okay, keyboard. Next comes the keyboard interfacing. Keyboards, they are nothing but keys, they are nothing but mechanical switches. They are like switches. When you press it up, it vibrates and then it comes to a settled value. Okay, so after settling the value alone, the value of the key should be read. So therefore, there are some process involved in keyboard interfacing. Those are key press detection of whether any key is been pressed. Next, debouncing the key because the key has to settle to a value. Then key decoding. Okay, these are the 3 steps involved. So let me take up a matrix keyboard. So the keys are arranged in the form of a matrix. Okay, the keys are arranged in the form of a matrix. Okay, so if at all any key is been pressed, then if this key is going to be pressed, then this 5 volt is going to go up here. Okay, this 5 volt will be connected up here. So that means row 0, one of the key is pressed. But which key is been pressed? That has to be scanned up. Okay, because row 0 press, then here you get the value as 0. So that means in row 0, one of your keys, because I can name this as A, B, C, D, so on so. So whether the key A is pressed or B are pressed or C is pressed, because all lies in the same row. So we have to identify which key has been pressed. So for that, your processor will send. Okay, it will just throw the values here as 0 and it will identify. So like how you identify an element in a matrix. You will scan row, column, the corresponding, the row and column where it meets, that is the value you read. The same way here. So a row value will be obtained whenever a key has been pressed. The column value will be obtained by doing a scanning process. So now we'll see what is the purpose of your dedicated hardware. Okay, the purpose of your dedicated hardware is because in case of keyboard, there are 3 processes involved. To do this 3 process, we need a dedicated hardware. If you try to do it up everything in software, then most of the time your processor will be wasting up its time. Then in case of your LED interfacing, to reduce the power dissipation, we go for a multiplexed display. Then the multiplexed display has to be refreshed up at a periodic interval. So again, if you have a dedicated hardware which can take up that, then the processor time could be utilized in a better manner. So that is the purpose why we go for keyboard display interface controller. Okay, so using your 8279, you can connect maximum of 64 keys in an encoder decoder mode, and 16 display devices can be interfaced, and 8 different commands could be given to perform the various functions. So this is your keyboard display controller. You could see 8-byte FIFO sensor RAM. That means FIFO sensor RAM is for keyboard section. So 8 keys could be stored in your FIFO sensor RAM. And 16-byte display memory. So your processor can write maximum of 16 display characters to be blown up. Okay, so those codes could be written for this, or the character which to be displayed could be entered up here so that it could be lit up at your display unit. Next, we'll see the detailed structure of your 8279, that is the block diagram. So you can see here RL0 to RL7 shift and control. RL0 to RL7, these are nothing but the columns of your matrix keyboard. Shift and control is as usual what we have it in your keyboards. Then SL0 to SL3, this is a scan counter which is used for both keyboard as well as the display. So SL0 to SL3, for a keyboard interface, we will take SL0 to SL2. That means 3 to 8 decoder if we use, then I get 8 rows. So this forms 8 columns. So 64 keys could be connected. If at all any key is been pressed, there is a dedicated hardware which debounces this key and then it sends the value to your FIFO sensor RAM. So once the FIFO sensor RAM data is been entered, then immediately the status of your FIFO sensor RAM gets updated. It is no more empty. Then immediately an interrupt request is been sent to your 8086 processor so that the processor can come and read the key that is been pressed. Then you can see here the IO control signals, read signal to read the key press, write signal to write the display which is to be written up. Then chip select, it is to enable your 8279 and A0. If A0 is equal to 1, the data buffer will contain, okay, it is your control or status information. If A0 equal to 0, then this will be a data information. And coming up here, you can see the display registers, out A0 to A3 and B0 to B3. So this could be used as your 7 segments values like A to G and decimal point. So you can either use it like this, or A0 to A3. You can give it to a BCD to 7 segment display controller. Okay, you can drive your 7 segment display using a BCD to 7 segment display controller. So for that you can feed up these 4 values. Okay, and you can select any of the one display device which you want by using your scan lines. Okay, by using your scan lines, if you pass it to 4 through 16 decoders, then out of the 16 decoder, which one has to be selected, you can fix up this. Then, so this is being driven by your 16 by 8 display RAM. So the processor will read through a program, it will write what are all the characters to be displayed here, and this goes to the display register and this takes up. Here the timing and control register take care of your refreshing time. Next, see the pin details of 8279. So it is divided into 4 sections: CPU interface section, display section, scan section and keyboard section. In case of your keyboard section, RL0 to RL7 shift and then control keys. Then in case of your scan section, it is SL0 to SL3. Then for your display section, out B0 to B3 along with A0 to A3. Then BD bar, this is blank display. Okay, then CS is to enable 8279, and A0, I said if the value is going to be 1, it is going to be control or status information, or A0 equal to 0, this will be the data information. And DB0 to DB7, it is the data lines. Read, write, reset. Whenever the reset is being set, whenever the processor undergoes a reset, here the values entered in your display RAM and FIFO RAM will be cleared. Then keyboard section, you have RL0 to RL7. So those few pin values are being here. Then clock, it is for to decide your refreshing time, and interrupt request is to interrupt your processor whenever a valid key press is being done. So CPU interface section, you can see it is the data lines, the interrupt request, clock, reset, so which I have explained earlier. And in case of keyboard section, RL0 to RL7, it connects to the column of your keyboard. And there are 2 ways by which your key could be scanned, that is 2 key lockout and N key rollover. 2 key lockout, when 2 keys are pressed simultaneously, the first key is considered and the second key is discarded. In case of N key rollover, simultaneous N key press will be accepted and it will be stored in your FIFO sensor RAM. So the format of your data which is entered in a FIFO sensor RAM is this. So you have the control bit, shift bit, then 3 bits for rows, row 0 to row 7, which represents row 0 to row 7, then 3 bits for columns, it is column 0 to column 7. Then you have the display section. So display section, you have got A0 to A3 and B0 to B3. Okay, and you have got a 16 by 8 display RAM. So where the processor will be written up the information, the segments to be displayed. So SL0 to SL3, this is your scan counter for both your keyboard and display section. So you can use a 4 to 16 decoder to generate 16 lines for multiplexing of your display. So I have used Leo Gibson and Douglas B. Hall textbook as my references. Thank you.